Hello and welcome to section 6.4. I'll try to keep this one a little bit shorter. I know that previous videos have been a little bit longer. We're going to be working with our first shortcut today, dealing with similar triangles. We talked about similar polygons. Now we're going to work with specifically similar triangles using angle-angle similarity postulate. We're going to skip through all this stuff and just jump right to it. Basically, what we're doing here is we're learning a couple shortcuts, and the reason why we have just angle-angle, so if two angles, one triangle are congruent to two angles, another triangle, then the two triangles are going to be similar, meaning they're going to have the same shape, but one's going to be bigger or smaller than the other one in terms of size. The reason why we don't need these third angles to be congruent is because if two angles of one triangle are congruent to two angles of another triangle, the third angles theorem will say that the third angles have to be congruent. So it's redundancy at that point. So just check to see if two angles are congruent, and then the two triangles are going to be similar. Okay, so we're going to show that the two triangles are similar by using angle-angle. So with this one here, I'm going to separate these. It's a good habit to get into. This is A, E, B, and then this is going to be the larger one, A, D, C. And we have this angle congruent to this angle here, and angle A is reflexive, and there you go. That's enough information there to show that the two triangles are similar. Here you have some parallel lines. We're going back to our alternate interior angles, and you're going to see the first thing I do is I make that Z right there, that N. Those two angles right there are going to be congruent, and then I'll just mark my vertical angles because that's easy enough, and you have two angles congruent there. You could have also said R and T are congruent by alternate interior angles. So there's multiple ways of doing that one there. Okay, this one here, all these angles, since they're equal, have to all be 60, and all these angles here have to be 60. Oh, when it says to write a similarity statement, that's just kind of ridiculous. I mean, it's just triangle is congruent to triangle, or sorry, similar. So with the similarity symbol there. That's all they're looking for there if they do ask you that. And then this one here, let's see, they want to show CDF and DEF. So this left one and then the right one. Okay, so I'm going to use the triangle sum to show that this angle here has to be 58 degrees. If this is 90, then this is 90, and this here is 32. So you have plenty of information there just using triangle sum to show that these two angles are congruent, and these two angles are congruent, and then the right angles are congruent. So they're all congruent. So that's enough information to show that those are similar. A flagpole casts a shadow that is 50 feet long. Okay, so this is 50 right here. And at the same time, a woman standing nearby is 5 feet 4 inches. Okay, so I got 5.33. I'm going to go with all inches. Actually, let's go with 5 feet 4. That'd be 5 1/3 feet. Okay, let's go with that. Let's see if we can do it with that. Cast a shadow that is, oops. The woman is 5 feet 4 inches. Okay, that's her height. And her shadow is 40 inches long. Okay, so I'm going to go with inches on this. I'm going to grab a calculator. So I was originally going to try to do everything in feet, and then I just realized that that probably isn't going to work out very well because there's too many things with inches in it. So 5 feet is 5 times 12 is 60. So 64 inches. 50 feet shadow times 12 is 600 inches. And the shadow of the lady is 40 inches, so we can just leave that as 40. They want to know how tall the flagpole is. Well, here's what we got going on. There's a triangle here and here, and what we're dealing with is the sun has sunlight, and we're assuming that the sunlight has the same angle, and so we have the right angle here. Those are congruent, and then we're basically saying that those two angles are going to be the same there because the light's hitting those, creating the shadows. And so we can say that the two triangles are similar by angle-angle. And then we can do 64 over 40, and there's multiple ways of doing this. We'll call the flagpole's height x equals x over 600. So we're doing actual over shadow equals actual over shadow. And then you could just cross multiply. 64 times 600 equals 40 times x. Divide by 40. So 64 times 600. And then divide that by 40. This is going to be in inches, of course. So we have 960 inches. And we'll convert that into feet by dividing by 12, which is 80 feet. And there's your answer. All right, that's all I got for you guys. Here is your assignment. Let me know if you have any questions. Glad I could keep this under 6 minutes.